Okay, very good morning, my dear friends. Welcome to today's
Good morning,
session.
sir.
Dr.P.Manjula Madam Garu and other CPGET 2024 aspirants, hearty welcome. Madam, today is going to explain about the anomalous secondary growth in different plants. So, Dr. P. Manjula Madam Garu, Asst.Professor, Department of Botany, RBVR or Women's College Autonomous. Madam, please welcome. I have given a chance to you. Share your screen and start your session, madam. After madam class, we have another two classes, my dear friends, 2 p.m. and 3 p.m. So 1 to 2 p.m. lunch period. Okay, madam, please welcome and start your session.
Okay, thank you, sir.
Madam, please click on slideshow.
Sir, is it okay?
Yes, madam. Yes, proceed.
Okay. Good afternoon, Vananda. So today's topics are anomalous secondary growth in Echinanthus. So mainly in the stems, Echinanthus, Borreavia, and Bignonia. So already we discussed about the anomalous secondary growth. So anomalous secondary growth means the secondary growth which occurs other than the normal vascular cambium and it may show some abnormal activity. So it is called as the anomalous secondary growth. So again, anomalous secondary growth, it may be a adaptive or non-adaptive. So if the anomalous secondary growth, if it is useful to the plants, it is called as the adaptive. And if it is not useful to the plant, so it is called as the non-adaptive anomalous secondary growth. So first one is the anomalous secondary growth in Echinanthus. So generally a cross section of the young stem. So Echinanthus, it belongs to the dicotyledonous. So is a cross section of the young stem which shows ridges and furrows. So the epidermis is single layered and consists of here tabular cells. So and it is single layered epidermis is present and covered with thick cuticle on the outside. So same generally how the anomalous secondary internal structure of the dicotyledon is there. So here also same. It contains a single layered epidermis and it is covered with the thick cuticle. And here the epidermal hairs also present and they are long and multicellular. And the cortex here shows hypodermis, general cortex, and endodermis. So below the epidermis, that is alternating groups of cholenchymatous and chlorenchymatous cells are present. So these cholenchyma, which is well developed inner to the ridges. So in the ridges region, so we already discussed that here the cross section, when we show the section, say young stem, so it shows ridges and furrows. In the ridges, it is made up of cholenchyma. Okay, hypodermis is cholenchymatous at the ridges, and in the furrows, that is chlorenchymatous. So general cortex, which shows colorless so here the cortex is made up of parenchyma cells with intercellular spaces. So here the endodermis is not very distinct and it is made up of thin-walled cells. So this is the structure of the Echinanthus. So it contains outer epidermis with the hairs and here cholenchyma, it is present at the ridges. And here it is chlorenchymatous, hypodermis is chlorenchymatous. And next one is the here endodermis. So single layered endodermis is present. And next one is the pericycle. So pericycle which lies inner to the endodermis. And it consists of perivascular fibers, that is the sclerenchyma and parenchyma. So here pericycle which is made up of alternating sclerenchyma and parenchyma. So the normal ring of vascular bundles are which are separated by the wide medullary rays of parenchyma. So here the medullary rays are also present. So the bundles are conjoined, collateral, endarc, and open. So vascular bundles, they are arranged in the same radii and they are collateral, that is present on xylem alternating the phloem in the same radius, and endarc, that is the cambium is present. That is endarc means that is protoxylem towards the center and metaxylem towards the periphery, and open, that is cambium is present, and phloem towards the outer side and xylem towards the inner side. So a distinct strip of cambium is present between the phloem and xylem. So here, in addition to the normal ring of vascular bundles, here the two medullary bundles are present. So in the center, two medullary bundles are present. So these are the medullary bundles. So here this is the vascular bundle only. So here that is xylem. This is the xylem. And here this one is the phloem. So central to medullary vascular, large medullary vascular bundles are present in the center. So they lie opposite to each other, and in Echinanthus aspera, the two bundles may remain free throughout the length of the plant, or it may be fused in the lower internode. So generally they are free, they are not, and they will not undergo the secondary growth, and they are present like that only. Okay, so they are free throughout the length of the plant. So next one is, so this is the structure of the internal structure of the echinanthus stem. So by identifying these medullary vascular bundles, we can identify that. So this is the echinanthus stem. So it contains outer epidermis. Next one is the hypodermis, parenchymatous, and collenchyma is present at the ridges. And here also in the pericycle, sclerenchyma and parenchyma cells are present. So at the region of the vascular bundles, that is the collenchyma is present, sclerenchyma is present, and in normal, so parenchyma cells may be present. So this is the normal, that is the structure of the echinanthus. So when there is a fusion, the two bundles form a single amphizylic vascular bundle, that is phloem in the center and xylem on its either side. So here we discussed that. So generally these two vascular bundles are free. But when they are fused, they form the two bundles, form a single amphizylic vascular bundle. That is amphizylic means that is phloem in the center and xylem on its either side. So ikkada structure chudandi. So xylem which is present in the center and phloem on outside. So when they fuse, they form the phloem in the center and xylem on its either side. So secondary growth. So this is the normal structure of the echinanthus. So normally the dicot stem. So but here the special character is presence of the secondary, that is medullary vascular bundles. Okay. So during the secondary growth, the primary vascular bundles are in a ring inner to the pericycle. Strips of this cambium arise between. So during the secondary growth, what happens? So the ring formation, the cambial ring formation will takes place. The strips of the cambium arise between these bundles and join the intravascular cambium of the vascular bundles, forming the ring. So the cells which are present in the vascular bundles region becomes meristematic and they act as the cambium. So here a cambial ring is formed. So the activity of this cambium is like that of the Borrelia stem. So here in the Borrelia also same like this. So they become the cambium form, the ring like a cambial ring is formed, and they form the intravascular cambium forms the secondary xylem towards the inner side and secondary phloem towards the outer side, intravascular cambium only. So its activity is very limited. And here the intervascular cambium, which forms the conjunctive tissue between the bundles. So this conjunctive tissue between the secondary xylem masses is formed of thick lignified walls. So what happens? So generally during the secondary growth, so total cambial ring will be formed from the intravascular and intervascular. So they form the secondary cambial ring. So this cambial ring, they produce the secondary xylem towards the inner side and secondary phloem towards the outer side. But here what happens? Only in the intravascular cambium, that is the intravascular cambium means the cambium which is present in the vascular bundles region. So this region only, okay, they producing the secondary xylem towards inner side and secondary phloem towards outside, and the vascular cambium that is present between the two vascular bundles. So here they form the intervascular cambium. This intervascular cambium, they are producing the conjunctive tissue. So conjunctive tissue means it may be made up of the parenchymatous cells or collenchymatous cells. Okay. So here it producing the conjunctive tissue between the bundles. So this conjunctive tissue between the secondary xylem masses is formed out here. The secondary, so it produces inside towards the inner side, the produced conjunctive tissue, they form the thick lignified walls. Okay, so this is the here what happens. So this cambium, generally this cambial ring, during the secondary growth, what happens? So total this cambial formation of cambial ring will takes place, and they produce a secondary xylem towards inner side and secondary phloem towards outside. But here only in the intravascular cambium, that is the cambium, that is the cambium strip which is present in between the xylem and phloem, only producing the secondary xylem towards inner side and secondary phloem towards the outside. And the cambium strip, that is intervascular cambium, that is present between the two vascular bundles. So it producing the conjunctive tissue. Okay, so this is the abnormal activity. So as an extrastellar cambium appears in the pericycle and produces the secondary vascular bundle. So which is again after some time what happens? This growth will stops, and again extrastellar cambium will produce, and which appears in the pericycle, and it produces secondary vascular bundles which at the first and remain irregularly scattered. So this conjunctive tissue which is produced by the cambium becomes lignified. So the secondary vascular bundles lose their identity. So as a result, the thin-walled phloem of secondary vascular bundles appear as a distinct patches in the secondary lignified. So these axes, that is conjunctive tissue, they becomes lignified. Okay, and here only this phloem, the secondary vascular bundle, the phloem of the secondary vascular bundles, they are thin-walled and they are scattered in this patches, secondary lignified tissue. So hence it mistaken that the interxillary are included phloem. So due to appearance, so we may confuse that. So it may be included phloem. That is, phloem is embedded in this xylem. So the medullary bundles increase in size by the activity of the cambium. Okay, so this is about the anomalous growth. Main points are here. The internal structure of the acanthamus is similar, but here special character is that is presence of the medullary vascular bundles in the center, but they do not have any activity, and they may be fused to form the normal, involved in normal secondary growth. Otherwise, they will not. They are free, but here only the vascular bundles during the formation of secondary growth. So here the formation of cambial ring will take place, and here this cambial ring only at the region of intravascular region, that is the cambium which is present between the xylem and phloem, only involved in the production of secondary xylem and secondary phloem. And the intervascular cambium, they are, so conjunctive tissue is nothing but it is the conjunctive tissue. It is nothing but it is made up of parenchyma or collenchyma, and here it may be lignified. Here in this it is lignified. Okay. So next one is the anomalous secondary growth in Borhavia stem. So second one is Borhavia. It belongs to abnormal causing the medullary vascular bundle. So here the medullary present. So like the acanthamus, here all the vascular bundles are present. So the transverse section which shows epidermis, parenchymatous hypodermis, parenchymatous cortex, endodermis, and single-layered pericycle. So this pericycle which consists of parenchymatous cells with isolated patches of sclerenchyma. So the so here also the it is also similar, that is the dicot stem. So it is also, it contains outer epidermis and parenchymatous hypodermis, parenchymatous cortex, endodermis, and single-layered pericycle. So these are similar. So the pericycle which is also consists of parenchymatous cells with which are isolated patches of sclerenchyma. So the primary vascular bundles are conjoined, collateral, open, and end arc. Here also the primary vascular bundles, conjoined, collateral, open, and end arc. So these bundles occur in 3 concentric rings. So in Borhavia, so here vascular bundles, they are appear in 3 rings. So the innermost ring, which consists of 2 large vascular bundles, which are present in the parenchymatous pit. So they lie opposite to each other with their protoxylem facing each other. And middle ring, which consists of 6 to 14 small vascular bundles. And third one is the outer ring, which consists of 15 to 20 smaller vascular bundles of these are the normal vascular bundles. So here 3 rings of vascular bundles are seen in the Borrhavia. So outer ring, which consists 20, and middle ring 6 to 14, and inner ring 2. So the middle and inner rings of the bundles are considered as medullary bundles. So these inner and middle ring of vascular bundle, they are the medullary bundles. So in Ecranthus, only 2 medullary bundles are present, but here 2 rows of medullary bundles are present in Borrhavia. So this is the structure. So these are the 2 medullary vascular inner, and these are the middle, and here this one is the outer ring of vascular bundle. So here also it contains epidermis, collenchymatous hypodermis, and parenchymatous cortex, endodermis, and here pericycle. Okay, so this is the structure of the Borrhavia stem. So next one is the secondary growth. So during the secondary growth, the 2 central bundles and the middle ring of bundles increase in size due to limited extent by the activity of the vascular cambium. So during the secondary growth, so here these 2 central bundles and the middle ring, they increase in size due to the activity of the vascular cambium. So, but here intervascular cambium do not develop. Here intervascular cambium, only the cambium which is present between the xylem and phloem will increase. So, due to which here the secondary growth will takes place. Here there is no intervascular cambium formation. So, the outer ring of vascular bundles, which is responsible for the most of the secondary growth in the stem. So, the outer ring only involved in the more amount of production of the secondary growth. So, the vascular and intervascular cambial strips unite to form the complete cambial ring. So here the outer ring of vascular bundles. So during the secondary growth, the vascular or intervascular and intravascular cambium unite to form the cambial ring. This cambial ring behaves in an unusual manner. So here the cambium, which produces secondary xylem vessels towards the inner side and secondary phloem towards the outside only in the vascular region. So here also same. Okay. So only at the region of vascular bundles region, the cambium which is present between the vascular cambium only producing the secondary xylem and secondary phloem. So in between the bundles, the intervascular cambium which produces the thick-walled parenchyma cells to the inner side and thin-walled parenchyma cells to the outside. So the intervascular cambium, it producing the thick-walled parenchyma to the inner side and thin-walled parenchyma to the outside. So instead of producing the secondary xylem towards inner side and secondary phloem towards outside, it is producing the parenchyma cells only. This parenchyma cells also thick-walled parenchyma cells to the inner side and thin-walled parenchyma cells to the outer side. So the thick-walled cells which are formed in between the secondary xylem vessels, it is called as a conjunctive tissue. And after some time, this cambium ring stops its activity, and then a new cambial ring is formed external to the secondary phloem. So after some time, so this cambial activity will stop, and other new cambial ring is formed from the external to the secondary phloem. And the parenchyma cells and pericycles take part in the formation of secondary cambial ring. So this secondary cambial ring, which is formed from the pericycle cells and parenchyma cells, which are present at the outside the secondary xylem phloem. So this cambial ring is called as the accessory cambium. Okay. So the cambium which is produced other than the vascular bundles region. So it is called as a cambial, accessory cambium. So this accessory cambium which is formed from the cells of the pericycle. So here the accessory cambium which is formed from the pericycle region. So this accessory cambium which behaves normally and produces the secondary xylem towards inner side and secondary phloem towards the outer side. So in between the conjunctive tissue is formed. So after a period of activity, so this cambium also stops its function, and another ring of cambium which arises outside. So again which behaves in the same pattern like that. So after some time, again this accessory cambium will stop its activity and another cambial ring will be formed. like this. So in this manner, 4 to 5 successive rings of collateral bundles are produced embedded in the conjunctive tissue like this. So here this secondary growth will abnormal activity will continue for 4 to 5 successive rings. So as secondary vascular tissues are produced in the stellar region, a new protective covering. So due to the activity of this secondary growth, what happens? The epidermis will rupture, and here in this region, so periderm is produced in the cortex region. So phellogen or carcemium is initiated in the hypodermal region. So it produces the phellum or carc to the outside and phelloderm or secondary cortex to the inner side. So this phellum, phellogen and phelloderm constitute the periderm. So this is about the anomalous secondary growth in Borrelia. Okay, so in Borrelia, that is when we observe the TS of the stem, so it is normal like the dicot stem, and that is it contains outer epidermis and collenchymatous hypodermis and parenchymatous cortex, next endodermis and pericycle. But here in the vascular bundles, only here 3 rings of vascular bundles are present. So outer ring consists of 15 to 24, 15 to 20 vascular bundles, and middle 6 to 14, and inner 2 large vascular bundles. So during the secondary growth, this outer ring only, so generally the middle and inner ring, they produce the normal, they increase in size due to the cambial activity. But main secondary growth will take place from the outer ring only. So this outer ring which produces, so during the secondary growth, so this here the formation of the cambial ring will take place. Okay, so that is the vascular bundles are joined to form the inter and intravascular cambium strips are joined to form the cambial ring, and it producing the secondary xylem towards inner side and secondary phloem towards outside only at the region of intravascular region. That is the intravascular region means the between the xylem and phloem region, the cambium only producing the secondary xylem and secondary phloem. So in between these vascular bundles, say they producing the conjunctive tissue. Okay, after some time, this activity will stop and another new accessory cambium will develop from the pericycle region like this. So 4 to 5 successive cells will be formed. Cambial cells will produced. So this is about the anomalous secondary growth in Borrelia. So another one is the anomalous secondary growth in Bignonia. So this Bignonia, it belongs to the family Bignoniaceae. So Bignonia species, these are the OD climbers, and a young stem which shows ridges and furrows. Here also it shows ridges and furrows. So epidermis, it is the outermost layer with thick cuticle. So this is the structure of the Bignonia. So it contains outer epidermis, hypodermis, cortex, endodermis, pericycle. Okay, so epidermis is the outermost layer with a thick cuticle on its outer side, and collenchyma is prominent below the ridges and in furrows. So some collenchyma may be present. So here also in between the ridges region, collenchyma is present, and in the furrows, parenchyma may be present. So the cortex is made up of few cells, layers of parenchyma. Endodermis is not very distinct. It may be present. So the pericycle, which shows alternate bands of sclerenchyma and parenchyma. Vascular bundles are here collateral open with endark xylem. Endark means that is protoxylem towards center and metaxylem towards periphery. So they are arranged in the form of a ring around the periphery of the pith. So secondary growth. So during the secondary growth, the inter and intravascular cambial strips become active to form the normal ring of cambium. So in the initial stages, this cambium behaves normally and produces more secondary xylem and less secondary phloem. So during starting stages of secondary growth, it producing the secondary xylem, more amount of secondary xylem towards inner side and less amount of secondary phloem towards outside. Subsequently, at 4 points, so after some time what happens? So they behaves abnormally and they produces at the mainly at the 4 points, the cambium begins to produce more secondary phloem on the outside and relatively small amount of secondary xylem on the inner side. So it produces more amount of secondary phloem towards outside. So normally నార్మల్గా ఎలా ప్రొడ్యూస్ చేయాలి? ఇట్ ప్రొడ్యూసెస్ మోర్ అమౌంట్ ఆఫ్ సెకండరీ జైలం టువర్డ్స్ ఇన్నర్ సైడ్ అండ్ లెస్ అమౌంట్ ఆఫ్ సెకండరీ ఫ్లోయింగ్ టువర్డ్స్ అవుట్ సైడ్ ఈక్వల్ గా. సో బట్ హియర్ ఓన్లీ at the 4 points only it producing more amount of secondary phloem. So this is the abnormal activity in the bignonia. And here this result in the formation of 4 deep wedges of phloem projecting into the secondary xylem. So the secondary xylem appear to be rigid and furrowed. So ఇక్కడ మనకి ఎలా కనిపిస్తుంది? So it shows ridges and furrows due to the production of more amount of secondary phloem only at the 4 regions, 4 points. So the cambial ring breaks up. So due to this activity, what happens? This cambial, due to irregular activity, so this cambial ring breaks up into number of strips due to this anomalous behavior. So some cambial strips occupy the base of the phloem wedges, and the remaining strips occur at the projecting edges of the xylem. So each phloem furrow is protected by a bar of sclerenchyma, which gives mechanical support against the crushing pressure of the secondary xylem. So this sclerenchyma bars which are present at the furrows of this phloem, they helps in the they gives mechanical support. So initially the number of phloem furrows are 4 in number. So additional furrows may be formed in older stems. So as a stem grows, so here it may be more than 4 furrows may be observed in the older stem. So in this way, so the xylem, secondary xylem, this secondary phloem broken into vertical bignonia as in, so it is the adaptation to their climbing habit into the vertical. So this becomes the adaptation. So because it is a woody climber, so this adaptation due to presence of this abnormal activity, so it is useful to the plant. So in high wind, the stems are subjected to compression or pulling. So so due to which, so when they are subjected to cutting, so if these sclerenchyma cells, there may be, if they are absent, so due to which, so they may be breakdown. But due to presence of this abnormal activity and due to the presence of these sclerenchyma strips, it helps the plant. So a solid cylinder of xylem is likely to break under such conditions. So furrows of this phloem present in the xylem act as a shock absorber and allows to bend during the strong winds. So this so it is adaptive anomaly. Bignonia, anomalous secondary growth in the bignonia, it is the adaptive anomaly. That is, it is useful to the plant to the high winds. So it can be protected by high winds due to presence of this sclerenchyma. They gives mechanical support. So here the periderm is produced in the cortex region due to the activity of the phyllogen. So this is about the anomalous secondary growth in Echinanthus, Borrehavia, and Bignonia. So that is the dicot stems. So in first one, in Echinanthus, so here central medullary bundles are present. So here main anomalous secondary activity is due to here also, that is they producing the only at the region of vascular bundles region only, it producing the secondary xylem and secondary phloem, and in between them it producing the conjunctive tissue. In Borrehavia, here 3 rings of concentric rings of vascular bundles are present, and here the outer ring is involved in the secondary growth, and here it is also producing only at the vascular region, that is vascular bundles region only, it producing the secondary xylem and secondary phloem, and the remaining region it producing the conjunctive tissue. Okay, so in next one is the in Bignonia. So only here the only one cambial ring, it producing only at the 4 regions only, it producing more amount of secondary phloem towards outside and less amount of secondary xylem towards inner side. So due to which it shows rigid and furrows, and it is the adaptive anomaly in Bignonia. So this is about the anomalous secondary growth in dicot stems. Any doubts?
Ma'am.
Okay, my dear friends, regarding of today's class, if you have any doubt, please ask our respected madam.
Otherwise, I will going to wind up the session. Okay, my dear friends. So unmute yourself and interact with our respected madam. Okay.
Okay, sir.
No doubts.
Sir, I'll ask sir now.
Okay. Okay. Ask our respected madam. Madam.
Okay. Okay, sir. Nayana.
Ma'am, you said that in Acranthus stem, no, ma'am. You
Okay.
explained all general characters and diagram, no, ma'am.
Okay.
Once I explained the about the parts of diagram, ma'am. All parts I understand, but the diagram I can't understand.
Echinaanthus. So this is the Echinaanthus stem. So it shows central two medullary vascular bundles. So it contains outer epidermis and the epidermis. So it produces hairs, and the next one is the cortex. That is hypodermis and general cortex. And here these are the medullary vascular bundles. They do not involve any secondary growth. They are free. Okay. So the outer ring only involved in the production of secondary production of the secondary growth.
Okay, ma'am.
Okay.
Okay, ma'am.
Okay.
Ma'am,
Tell me.
ma'am, these about Acranthus, these diagram parts they'll ask the ma'am related questions.
Regarding Echinaanthus stem. So how the anomalous secondary growth occurring in Echinaanthus stem. So that is outer ring or middle ring, or how this secondary growth anomalous habit, how this anomalous activity will occurring.
Okay, ma'am.
Okay. Okay.
Okay, ma'am.
Okay.
Okay, madam, thank you very much. So anomalous secondary growth, madam has clearly explained today in different plants, Bignonia, Echinaanthus, Boravia, and other plants. So thank you very much, madam. Tomorrow we will meet once again. Thank you very much.
Okay. Thank you, sir.